All right, next page. Okay, find the derivative of x times ln of x squared. So what I see on this one is I see a little product rule. It's this times this. Okay, so let's go ahead and do that. So y prime is going to be the derivative of the first, which is 1, times the second, which is ln of x squared, plus the first, which is x, and then times the derivative of the second. Now, how do I derive ln of x squared? Okay, so look, I'm going to bring the 2 in front, so it's going to be 2 times ln of x. My new exponent, if you subtract 1, is a 1. And then times, now I have to go ahead and derive the inside. The derivative of ln of x is 1 over x. Okay, now let's do a little bit of cleanup here because it looks kind of gross. Okay, 1 times ln of x squared is still ln of x squared, plus, notice that the x's cancel out. This 1 is completely irrelevant, so it's just 2 ln of x. Now, when I look at my answers, I'm like, okay, that's not there. Okay, there is no ln of x squared, but except for a, but that's not the answer, right? So, but what I notice about my other answers, they all have an ln of x factored out. So maybe let's factor out an ln of x. So if I take an ln of x out, well, I have 2 of them there. If I take 1 out, I'm going to have 1 left, okay? And then if I take an ln of x out of there, I'm going to have a plus 2. So you guys, that looks like the answer is going to be C. Notice that they switched the 2 and the ln of x around, but it's the same thing because you're adding. Okay, number 24. Find the derivative of ln of the square root of 1 minus x squared. So let's do that. So y equals the ln of the square root of 1 minus x squared. Okay, so this is just chain rule all over the place. So the derivative of the ln of something is 1 over that something. Okay, times, okay, the derivative of the square root of something is 1 over 2 times the square root of that something. And then I still need to move to the inside. What's the derivative of 1 minus x squared? That's negative 2x. And again, you guys, do a little cleanup here. I see that these 2's cancel out. So what do I have left over on the top? I have a 1 times negative x, which is a negative x. And then I have the square root of 1 minus x squared times the square root of 1 minus x squared. You guys, remember when you multiply a square root by itself, the square root cancels out. So this is just 1 minus x squared. Now, this one's a little bit tricky. I don't see that answer, okay? And a lot of people will go for A because it's like the closest one to it, but don't fall for that. You have a negative on the top. This one doesn't, okay? And so I need to kind of fix this around and see what the heck happened. Now look, notice that some of them have an x squared minus 1. Let's see if I flip these around, okay? If I switch this to negative x squared plus 1, I just flip these around, right? And that's negative x, okay? And then maybe if I factored a negative out of here, leaving me with an x squared minus 1, now the 2 negatives are going to cancel and make a positive, which leaves me with x over x squared minus 1. So I don't think the calculus of this one was that bad. I really think the algebra simplification was kind of annoying though. All right, number 25. I have f of x equals the square root of e to the 2x plus 1, and I want to find f prime of 0. So let's find f prime of x first. Okay, so what is the derivative of the square root of something? Well, that's 1 over 2 times the square root of that something. Okay, and that plus 1 is there on the bottom. Sorry, guys, it looks like it's on the top. Okay, and then times, now I need to multiply by the derivative of that. So the derivative of e to the 2x is e to the 2x times 2. Remember the chain rule there? And the derivative of plus 1 is 0. So again, let's do a little bit of cleanup here. 2's cancel out. So I'm left with e to the 2x all over the square root of e to the 2x plus 1. But not quite done yet. I need to find f prime of 0, which means I need to replace all of these x's here with a big fat 0. So that's going to give me e to the 2 times 0 all over the square root of e to the 2 times 0 plus 1. So e to the 0 is 1, e to the 0 is 1, 1 plus 1 is 2 over square root of 2. Now again, I don't see my answer in here, okay? What did they do? Well, 1 over square root of 2, if you rationalize it, this is algebra 2 coming back to haunt you. This is going to be square root of 2 over 2, which is C. Okay? All right, number 26. This is a fun little problem. Okay, e to the xy equals 2. I want the derivative at the point 1 ln 2. So I'm going to do implicit differentiation because x's and y's are stuck together, right? So I have e to the derivative of e to the xy is e to the xy, and then it's times the derivative of xy, which is product rule. So the derivative of the first is 1 times the second, which is y, plus the first, which is x, times the derivative of the second, the derivative of y is dy dx. And then that equals the derivative of 2, which is a big fat 0. You guys, again, let's do a little bit of cleanup. I have e to the xy times 1 times y is y, plus this is x dy dx equals 0. If I want to solve for dy dx, I need to distribute this. So I'm going to get e to the xy times y. I'll just write as y to the xy plus x e to the xy dy dx equals 0. Okay, notice I want my dy dx's to stay, so all of this I'm going to keep on that side. So I have x e to the xy dy dx, and that equals, I want to move this guy to the other side, so it's going to be negative on the right, negative y e to the xy. That's gone. Okay, now to solve for dy dx, I'm going to divide. So it's going to be negative y e to the xy all over x e to the xy. That's kind of nice. So dy dx is just negative y over x. Now let's plug in the values. My x is 1, my y is ln of 2. So this is negative ln of 2 over 1, or just negative ln of 2. So my answer is A.